Okay, factor the expression completely. Negative 16x to the second plus 96x. Okay, so we have two terms right there. Okay, remember you're not putting x equals, okay? That solved the equation. You can't solve an equation without an equals, so you're getting the parentheses and leaving it. You're trying to rewrite it. It's like taking 20 and writing it as 4 times 5. So you're figuring out what times what equals this. So there are two terms. There's either 2 terms or 3 terms. This is 2 terms, so I would set up GCF and then difference of perfect squares. GCF comes first, then the difference of perfect squares. Okay, so you have x in the last slot, and you have a negative in the front slot. Now 16 and 96. Again, if the x is in the last slot, you have to factor out an x and a negative. Okay, so here's 16. There's 96, so you put 16. Okay, so remember that's multiply with the rainbows. Now you take this, whatever's inside here, the whole thing, and go up and divide. So negative 16 divided by negative 16 is 1. Then x second divided by x. Just x remainder. 96 divided by negative 16 is negative 6. Then x divided by itself just gets a wipeout. So you bring over your negative 16x. That's part of our answer. Then we cross this out and this out. So then I'm just looking at here, the GCF in the original problem. Make sure you place a GCF before you cross it out. Okay, now dots, first term has to be positive, and the second term has to be negative, and it is positive, negative. Okay, so we're good. Now we check to see if these are perfect squares. So 1 is 1 times 1. X is not to the second, so it can't be done. So as soon as something can't be done and written as something times itself, okay, that means this is not a difference of perfect squares. So you just bring that parentheses 1x minus 6 over here. Okay, next problem. X to the second power minus 4x minus 32. So that looks like 3 terms now. So it'll be GCF table. And we're not looking at this diagonal here. Okay, that's only for the perfect squares. So GCF. And then the t-table. Okay, so there's no x in the last slot, there's no negative in the front slot, then 1, 4, and 32 it would just be up in row 1, so we don't need that. So my ABC comes from here, so I take positive 1 times negative 32. And that's a negative, so that's a mismatch. And it's got to, so positive, negative, and it's got to add to equal what the B is in the middle, which is negative 4. So 32 divided by 1 is 32, so that's not negative 4. 32 divided by 2 is 16, then you plus those, it's negative 14, that's wrong. 32 divided by 3 is a decimal. 32 divided by 4 is 8. 4 plus negative 8, there's your negative 4. So you put in your parentheses, your mystery numbers. Now your A, the x to the second, is 1. Okay. So I'll be putting x times x, and then I'll be putting a 1 in front of each of our x's. Okay, so 1 and 4, so here's 1 and 4, that would be 1. 1 and 8, so here's 1 and 8, both in row 1. So both dividing in both parentheses by 1. 1x plus 4, and then 1 divided by 1 is 1. When you divide by something by 1, it's just itself. Okay, now make sure the two numbers I have attached to the front of the x's, 1 times 1, make sure that's your a, it is. And then the numbers behind the x's, 4 times negative 8 is negative 32, and that's your c. Remember, you're taking this ABC and rewriting into those two parentheses. This is replaced with this. Okay, 9x to the second power minus 49, so there are two terms here. Okay, so GCF DOPS. Okay, now there's no x on the end. There's no negative in the front slot. 9 and 49. So there's 9, there's no 49. So here's 9 again, no 49. So the only other place 9 is in row 1. 49 would eventually, row 1 would eventually make it to 49, but it's 1, so we do not do it. Okay. Okay, now DOPS. This has to be positive, this has to be negative. Okay, positive, negative, we're good. Now, the first term, 9x to the second. Well, 9 is a perfect square, that's 3 times 3. X to the second is a perfect square, that's x times x. So you attach an x factor on each of your 3's. Because 3 times 3 is 9, x times x is x second. It's like you're breaking this up into the... Then 49 is here, that's 7 times 7. Okay, so then this has been replaced with these two. Okay, 4x to the second power plus 3x minus 7. That's 3 terms. Okay, GCF table. Okay, so there's no x in the last slot, there's no negative in the front slot, 4, 3, and 7. That would just be 1, so we wouldn't do the GCF. Okay, so A times C. Okay, 4 times negative 7 is negative 28, so that is a mismatch of a positive and a negative. And we have to add the factors to try to come to positive 3. 28 divided by 1 is 28. That's negative 27. 2 and 14. 2 plus negative 14 is negative 12. Three is a decimal, so 28 divided by 4 is 7. So the 4 plus the negative 7 is negative 3, so we have to make that into positive 3. Positive 7, negative 4. So if you have the right number but the sign's wrong, you don't keep dividing. Okay? You have the right factor pair, you just need to change the signs. Now remember, we're taking, the point of this is to take this and rewrite it into the two parentheses, okay? So put in your negative 4, your positive 7, and your A, the x second, is 4, okay? So x second, we go x times x, and then we take that 4 and put it in front of each x. Now we divide. Don't look, if the numbers are identical, don't look at the multiplication chart. You just divide by 4. 4 and 7 are not identical, so they would be in row 1 together. So that would become 1x minus 1, and that would be, stay 4x plus 7. Now the numbers in front of the x's, the 1 and the 4, 1 times 4 is 4, and that should be what the A is. Negative 1 times 7 behind the x's is negative 7. That should be what the c is. So odds are pretty darn good that we did this correctly. Okay, negative 5x to the second power plus 125. So there are two terms there. So GCF, and then the difference of perfect squares. So we don't have the x, we do have the negative. And then 5 and 125. 5, and there's 125, just made it, so it's 5. But not x, because you don't have x here. So, remember, you just go multiply, then you go backwards and divide by this negative 5. Negative 5 divided by negative 5 is 1. Now, since I didn't put x under the division line, the x second will stay x second. 125 divided by negative 5 is negative 25. Then, when you do actually do something with the, when you have fill that out, then you need to put the GCF. You need to cross that out and cross all this out, okay? And then this is what you're looking at. Remember, Dobbs' first term needs to be positive, second term needs to be negative. Yes, yes. So you look at it. So here's 1, that's 1 times 1. And the x is actually to the second power, so we know that that's x times x. And then 25 is a perfect square, so that's 5 times 5. Okay, so I'm going to replace this with this. You can cross that out if you want. It's 1x, and then 5, 5. Okay, so 1x plus 5 times 1x minus 5. Okay, last problem. 10x to the second power minus 14x minus 12. So that's 3 terms. So that would be GCF followed up with the table. So there's no x on the end. There's no negative in front. 10, 14, and 12. Nope. Nope. That'd be 2. Okay, they're all multiples of 2. Just 2. They can't be a negative. There can't be an x. So you go up and divide by 2. So 10 divided by 2 is 5. Now we have this x second here, but we're not putting x on the bottom, so that x second stays. And then negative 7, and that x is going to stay, and negative 6. So you put your negative 2, and now this becomes the ABC. So positive 5 times negative 6 is negative 30. So that's a mismatch on the signs. It's got to add to what my B is, which is negative 7. That's negative 29. 2 and 15, that's negative 13. 30 divided by 3 is 10. That's your negative 7 right there. So A is 5x. Oh shoot, put in the parentheses first. So you put in your mystery numbers. And now A equals your x second. There's the A, it's 5x second. So x second we write as x times x. And then you place a 5 in front of the x's. So now you divide this down. So 5 and 3. 5 and 3 are in row 1, so I'd be dividing by 1 here. 5 and 10, both multiples of 5. It's 5x plus 3. 1x minus 2. Okay. So again, this ABC has been replaced with these two parentheses. Okay. So 5x plus 3. 1x minus 2. And again, one thing, the numbers in front of the x is 5 times 1 should be the a, 5. 3 times -2 should be the c. Okay? Has to be, not should be.